Hello, sir.
Hi, we have two problems. First, I'm late for my flight. Second, we have to go over some things. First, let's start with this.
Anna Maria Airlines. They have a problem. Professor Anna Maria's airline currently mandates a 400-mile-per-hour cruising speed for all their flights. However, in recent years, they've been facing reduced profits and increased fuel consumption. The professor now wants us to find the optimal cruising speed for her planes, as well as minimize the fuel consumption to help environmental friendliness.
First, we're gonna go over an example from internal information we gathered from Madrid to Moscow, which is 2,500 miles. The fuel consumption rate function is f of v equals 0.02 times v squared plus 500. You might be wondering what that is. V equals speed. 0.02 represents the effect of drag, which increases fuel consumption with speed. 500 is the baseline fuel consumption, which is constant.
Okay, so the ultimate goal is to reduce total fuel consumption. So we're given the fuel consumption rate, which is determined by f of v equals 0.02 v squared plus 500. We know that the formula for total fuel is f of v over v times the total distance, which is 2,500 miles. So in order to find the optimal point, we want to find the first derivative of f of v, which is 0.004 v, and we want to equal it to f of v over v, which determines the fuel to cover a unit distance at a given speed. In order to do that, we're gonna equal 0.004 v to f of v over v, and then we're gonna get that v squared equals 250,000. Once we get the square root, we get the optimal traveling speed to minimize fuel consumption of 500 miles per hour.
So in order to find the total consumption at optimal speed, we first need to identify the flight time, where we divide distance by speed, and since we divide 2,500 miles by the optimal speed, which is 500 miles per hour, and we get 5 hours for the flight time. For the fuel rate at 500 miles per hour, we just plug it in the fuel consumption rate equation, which is gives 1,000 gallons per hour. And regarding total fuel, we just do 5,000 gallons times $6 per gallon, which is the price, which gives us 30,000.
So to demonstrate the importance of flying at 500 miles per hour, we can compare it to flying at 400 miles per hour. Since we're going slower, the flight time is longer, it takes 15 minutes. Now here to find the fuel rate, we plug it into the fuel rate equation. We plugged in 400 miles per hour, and then we got 820 gallons per hour. So the total fuel spent is 5,125 gallons.
So now that we know that the total fuel consumption at 400 miles per hour is 5,125, we can know that even though we're going slower and the fuel consumption rate is less, since we're flying for a longer time, the total amount of fuel is greater than if we were flying at 500 miles per hour. This means that we're consuming an extra 125 gallons of fuel, which at $6 per gallon is going to be an extra $750 expense in fuel, and it would also emit an extra 1.1 kilograms of CO2. What does this mean? That optimizing fuel consumption and optimizing to find the ideal speed to travel is gonna make the company more profitable, but also reduce our environmental impact.
Again, from Madrid to Moscow, 2,500 miles. So here's a formula for fuel consumption in terms of altitude, which is h. It's also in thousands. So 0.01 h squared minus 0.3 h plus 5 times v, where v is equal to 500 and the height is in thousands of feet. This is the picture of the plane that will be used to do this flight. In addition to finding the optimal speed for Anna Maria Airlines planes, we also find the optimal altitude those planes should fly at for a distance of 2,500 miles. So this is the optimal fuel consumption rate formula in terms of altitude, which here is height in thousands of feet, represented by h in the equation. So it's 0.01 times h squared minus 0.3 h plus 5 times velocity v, which is 500 miles per hour.
Okay, so now that we have the formula for the fuel consumption rate, we can find the formula for total fuel consumption. So we know that the formula for fuel consumption is going to be times the the fuel consumption rate. So in order to find time, we know that we're traveling at 500 miles per hour and that the flight distance is 2,500 miles. So we know that the total flight time will be 5 hours. Then we multiply those 5 hours by the fuel consumption rate and we get the formula, which is 2,500 times 0.01 h squared minus 0.3 h plus 5. And now we find the derivative of the total fuel formula, which is going to be 2,500 times 0.02 h minus 0.3. And now we can find the critical point. So in order to do that, we equal the derivative to 0 and get a critical point at h equals 15, which is equal to 15,000 feet. Now, in order to determine whether this is a minimum or a maximum, we find the second derivative of the total fuel formula, which is going to be 2,500 times 0.02, which is 50. And since the second derivative is positive, this means that the critical point is a minimum. So this means that the total fuel consumption is going to be at a minimum at 15,000 feet. So this is the optimal speed to travel. So we have 15,000 feet, and we can now calculate the total fuel consumption, which is going to be 2,500 times 0.01 times 15 squared minus 0.3 times 15 plus 5. And by doing that, we get a total fuel consumption of 6,875 gallons. If we were to compare this to flying at 20,000 feet, we can also plug in 20 into a fuel consumption formula, which is going to give us 2,500 times 0.01 times 20 squared minus 0.3 times 20 plus 5, and a total of 7,500 gallons. What does this mean? That by traveling at 15,000 feet instead of 20,000 feet, we're able to save upwards of 500 gallons of fuel over the whole flight, which is equivalent to over $3,000 of savings over the whole flight.
Okay, so in conclusion, despite increasing the fuel consumption rate by traveling at a faster speed, the reduced flight time resulted in 2.5% less fuel consumption. By doing this, Anna Maria's airline can increase profitability, reduce prices, and most importantly, reduce carbon emissions. So minus 2.5% fuel expense, minus 2.5% carbon emissions, and minus 20% flight time. In addition, finding this ideal flying altitude can also help save fuel. For instance, cutting altitude from 15,000 to 20,000 feet reduces fuel consumption by 8.33%. Thank you very much.
Flight time.
And wait.
Thank you for flying with Ana Maria Airlines.
Yeah.